Okay, so last class we talked about a much simpler way to calculate arithmetic sequences if you were asked for like the 100th, 120th, 200th term, right? For geometric, we haven't talked about that yet, right? In arithmetic, it was the recursive where we needed to go and reference the previous term and then add the common difference to each term to get to the next term, right? And then we developed the explicit formula, which this will help us calculate any term as long as we know the first term and the common difference. Those are all the things that we needed. Today we are going to talk about the geometric sequence and the same thing. What if you're asked to calculate the 20th, the 30th, the 40th term of a geometric sequence? We're going to learn the explicit formula today. Before we do that, let's attach this to prior knowledge, right? Believe it or not, during growth, generally there is a cell called a mother cell where we derive from, right? And then during the division, it is called daughter cells, and they just automatically do this on their own. Each of these daughter cells then divides into two, and so on and so forth until the organism continues growing. Here is a sequence of how these cells work. 1, 2, 4, 8, and 16. Here's your task. I want you to tell me why this is a geometric sequence, identify the common ratio, and then I would like for you and your group to complete this table together, right? If there is 0 cell divisions, how many cells are there? That's rhetorical, but that's for you and your group to decide. I'm going to give you and your group 6 minutes for this. I'll be walking around starting now.
so close to reference, but I just need
All right, everybody, looks like most of us have already finished, so let's talk about it. Why is this a geometric sequence? There's a big indicator. Catherine, what do you got?
Because they're all being multiplied by a constant.
Good. That's a big number. I would remove the word constant, but we are multiplying a value to get to the next term. We call this what? If we're multiplying something in a geometric sequence, we call this what? A common ratio. And what is the common ratio for this sequence? 2. Right? 1 times 2 is 2. 2 times 4. 2 times 4 is 8. 8 times 2 is 16, so on and so forth. Okay, so at 0 cell divisions, how many cells do we have currently? 1. Okay. If there is 1 cell division, how many cells will we have then? 2. Good. Okay, help me out. 4. Okay, next. Okay, next. 16. Okay, next. 32. Next. 64. Next. Oh, true. My mind is going faster than my writing. Okay, next. 128. Okay, next. 256. Next. 512. Cool. Questions here. We should be able to kind of deduce this by now. Okay. So what we talked about in our previous lesson, we use a recursive formula for a geometric sequence, and I just want to remind you what that looks like. The nth term is the term we are trying to find, whether it's the 5th term, the 6th term, the 7th term, that is the term. That would be deduced by a sub whatever the term is. So n represents the term that we want, right? A sub n minus 1 represents the previous term, the term before it. So if we're looking for the 5th term, right, a sub 5, that would equal what? A sub 4, but how do we get there though? What's the operation there? The 5th term minus 1. This is how we get the previous term here. And then all we did was just we multiplied the common ratio to get to the next term. Okay? I want you to practice this. I want you to practice using recursive formulas. Here's the sequence that I want you to follow. 4, 12, 36, and 108. I want you to write it in using the recursive formula. So I'm going to do the first one, right? We already know what a sub 1 is. That is equal to what according to this sequence? This one? We're just looking for the first term in the sequence. What is it? 4. Good. Okay. I know where you're going. So let's get there. A sub 2, the next term in the sequence, is equal to what? Let's write the formula. A sub what? 2 minus 1 times R, the common ratio. What is the common ratio? 3. And we're going to do that right now. A sub 1 times 3. We said a sub 1 is equal to what? 4. Good. Times 3. So then a sub 2, the second term in the sequence, is equal to 12. And the recursive formula will allow us to keep writing the next term based on the previous term. So here's my question to you. In the next 3 minutes, can you write all the way to the 5th term of the sequence? So 3 minutes on the clock, starting now. You and your groups. Yes, I would prefer you write it like this because you might end up with some questions on an exam asking you for the recursive formula. 5. Oh, make sure that you bring this a little bit more down because it's starting to look inline and then this is off. Make sure you're intentional about it. All right. All right, everybody, help me write the rest of the recursive formula. The next one we're looking for is a sub what? 3. That is equal to what? A sub 3 minus 1 times r. Good. Okay, let's simplify this. A sub, what is 3 minus 1? 2, good. Times, what is our common ratio? 3, good. Okay, what's a sub 2? 12. So 12 times 3. So then a sub 3 is equal to 36. Cool. Let's keep going. We're looking for a sub 4. This is equal to what? A sub 4 minus 1 times r. Good. This evaluates to what? A sub 3 times 3. A sub 3 is equal to 36, right? The connection there. Times 3. What is 36 times 3? 108. So then a sub 4 is equal to 108. Now what you were asked to do, the fifth term in the sequence. Yes, you could have just multiplied by 3. But what if in exam they ask you to write the recursive formula? Can you still write it? That's why it's important that we do this. So a sub 5 is equal to what? A sub 5 minus 1 times r. Okay. A sub 4 times 3. Okay. What is a sub 4? 108 times 3. And 108 times 3 is 324. So a sub 5 is equal to 324. That's the fifth term in the sequence. Using the recursive formula. But imagine everybody, what have we been doing? We have been having to reference back to the previous one, right? What if we can expedite the work and just calculate the 20th or the 100th without having to sit back and recall it? Again, this is what we call the explicit formula. And we're going to break it down. Are we ready? Very similar. A sub n is the term we are trying to determine. All right, we need to try and figure out what a sub n is. I'm not sure yet. Okay? Here's some things that are familiar. A sub 1. This is my what term? The first term, right? A sub 1 is the first term of the sequence. Now, something that this formula did not do is they didn't put parentheses along r. What is r again in this formula? My common ratio, right? What am I multiplying to my first term? It is important that you put parentheses. So I'm going to rewrite it so that we can see it much bigger. A sub n is equal to a sub 1 times parentheses r. And what do you notice about this? The n minus 1. Where is it located? It's an exponent, right? Meaning it's going to be, we're going to raise r to that power. And what is n minus 1? That references to what? The previous term, right? The most previous term that we had. So if you're looking for, if we were looking for 2, n minus 1 would be 1, right? It really just depends. For those of you that keep doing something like this, or this when we're doing the previous term, this is why I tell you be careful and be intentional about the way you write. That could be mistaken by a lot of things. And if you're in a hurry, you're going to make very simple and foolish mistakes, in my opinion, because you're not being deliberate about the way you're writing things. That is a sub 5 minus 1. So we should be writing it smaller and underneath the variable that we are looking for. What's up? For what? A sub n?
Like when you do lower or higher, how do you write that?
On delta math, you won't be worried about, they won't be asking you for a sub n minus 1. But there is a button. If you want, I can go over it. However, there is a button for in delta math. Raising anything to whatever power, there is an exponent button. Okay? I think on delta math is a sub b, or sorry, a to the power of b. This will allow you to create an exponent. And then from there, you just do n minus 1. Okay. I want to see if this is true. I'm going to test this myself. We're going to test it together. I want to see if in this previous sequence, if we're looking for a sub 5, are we still going to get 324? Let's check it. But help me write it. We're looking for a sub what? 5, good. And this is equal to, what is the first term of that sequence? 4, good. Times, what is my common ratio in that sequence? 3. In parentheses, I'm stressing it now, put the common ratio. Because if you have a negative number, it's going to make the world of difference. So put it in parentheses. All right, n minus 1. In the exponent, I should write what?
4.
It should evaluate to 4, but let's do it 5 minus 1 for now. But yes, let's now evaluate it. I am going to just get after you the same way I did 7th period. Do not attempt to do the mental math for this. I struggle with it. 1st period was a monstrosity trying to figure this out. Throw it in the calculator. Exactly the way you see it right here is the way you should throw it in the calculator. Whether you're using Desmos, whether you have your own handheld, that's how we do it. If you decide to do it by hand, order of operations tells me what. I should do what first? Parentheses, good. Have I evaluated everything inside of the parentheses? Yes. There's nothing else I can do to simplify the parentheses. What's the next operation in order of operations? Exponent. So I should deal with this next. What is 3 to the 4 power? No, it is not 27. It is 81. This is where I tell you, do not sit there and do the mental math for this. Just throw it in the calculator. Okay, and then last step, multiplication, right? 4 times 81 gives me what? 324. So a sub 5 indeed gives me 324, whether I'm using the recursive formula that we did on top or my new fast and efficient way, the explicit formula. How do we feel, everybody? Good? I do want us to get a little bit of practice referencing back the sequence using the cell division, right? We talked about the cell division. For the next couple of examples, I want you to write how many cells we will have if there is 11 divisions, 14, 18, and 22. Remember, we are using the sequence for the cell division, not this one. We're done with that one. Reference back the cell division sequence and tell me how many cells we will get if we have that many divisions. I'm going to give you and your groups 3 minutes for this. This is more than enough time for you to calculate this, especially with that formula. You don't need much. Go. give for 11? So we're about to put it out. Okay. 11 subdivisions. Well, hold up. Is that following up the formula or something? Okay, so let's follow that formula. That one. Okay, we need the first term, both first term, that is that.
It multiplies by 2 each time it starts at 1.
Go back. Makes it this one. What was the first term we had? 1. Okay, good. So then times, what's the common ratio there? Okay, times, what was the common ratio? Good. So, 2, good. Raised to what power? We're looking for. Go back. 81.
18
N minus 1. So we're looking for the 11. So 11 minus 1 gives me 10. So then that should be the excellent up there. Good. Do we need more time, everybody?
Yes.
All right, cool, cool. I'll give you 2 more minutes. 2 more minutes. Go. And then you just repeat that every single time. We're good? Less. Yeah. It doesn't matter. I mean, you're only using it for computation. You're not rounding it. Answer. That's what we're looking for. By the number that's in front of it. So it's the first term times the common ratio raised to n minus 1 power. Right, what is the common ratio for that one? For that sequence? Well, this one was, what is that? 11? 111? Wait, this is for subdivision? No, what's the first one? That sequence. I told you to go back to the subdivision. What was the first term in the sequence? What? Yeah. And then what was the common ratio there? 2, so that's what goes inside these parentheses. And then we're looking for 11 minus 1. Yeah, simplify that. All right, everybody, here we go. I want to set up the equations for those of you that were struggling a little bit. We are looking for a sub 11. That is equal to what? What was the first term in the cell sequence? 1 times, what's the ratio here? 2 raised to the 11 minus 1, right? Because we're looking for the 11th, but we need to subtract 1. Let's simplify it. A sub 11 is equal to 1 times 2 to the 10 power. And so then what's the 11th term in the sequence? How much is that? 1024. So A sub 11 is equal to 1024. Following this same pattern, A sub 14 is equal to 1 times 2, and we're just going to simplify it here. Raised to the what power? 13. which is equal to what? What is a sub 14 equal to? 8,192. Bam, done. Okay? Questions? Can I answer any so far? All right, let's keep going. A sub 18 is going to equal 1 times 2 raised to what power? Good. This means that a sub 18 is equal to what? 131,072. Okay? And last one. A sub 22, so the 22nd term in the sequence, is 1 times 2 raised to what power? 21. Which means that a sub 22 is equal to what? 2 million. I'm gonna say I guess so. 20,971,152. It's 2 million. It's 2 million. Questions, anybody? Can I answer? Please ask. Because some of you are lost and some of you aren't even saying a single word. I'm just calling it out how it is. I'd rather you ask me here rather than leave and not figuring out what I did. All right, let's scrap it and let's have this scenario. Let's suppose that the scientist starts with 5 cells in a petri dish. She wonders how the growth pattern would change each mother cell if each mother cell divides into 3 daughter cells. So here's my task to you. I want you and your groups to write the first 5 terms of the sequence, then calculate 13 divisions, and then 16 divisions. Let's just start by figuring out what we know. Okay? What's my first term in the sequence? I'm starting out with 5 cells. So a sub 1 is equal to 5. What is happening every single time I multiply, which we would call that what in a geometric sequence? R is equal to 3. You have enough information now to not only give me the first 5 terms, but to give me how many cells we'd end up if there were 13 divisions, and you would also tell me how many we have at 16 divisions. I'm going to give you and your groups about 5 minutes for this. Starting now. Finish already? What'd you get? 13. Not for 13. Gotta get that.
I got 13. I got 6, 5.
That's what I got.
Yeah,
That's what I got. What about for 15? I mean, sorry, 16. Okay. Let's check it. That's why I wanted to come and check. You seemed like you were finished, but now we're in this spot. Let's see. Well, yeah, what'd you get? What'd you get for... Did we all finish? Alright, talk to me. What did you get for 13? 16. Okay, what about for 16? Okay, Ruby. See it? Believe it or not, your calculator actually stops giving you numbers. It starts giving you operations. That's what it was.
Oh yeah, like if it's
Yes.
That was so bad last time.
Base. Oh, that. Wait, y'all talked about base already? Like base E?
But there's like scientific.
Scientific notation. Yeah, y'all did it last year? Yeah. No, we're supposed to do that early. It's crazy. It's cool.
Wait,
It takes a little bit. Right, because negative means that you gotta move it all the way to the left. Like crazy. It's tough.
that was like the scientific notation was like three of my questions. For 16, I like regular notation. Like,
This is gold. I would never recommend a calculator for you to ever purchase. This TI-84 plus CE, me and Chop, love them. Heck yeah, they're 150. They're 150.
my whole school required us to get them, and they were expensive, and then like we never used them.
Oh no, I
Y'all
mean,
were required to get them last year,
well,
or in 6th grade.
well, I just like to use it as my own personal calculator. We don't use it necessarily in class, but if you ever gonna make a calculation, that's why.
When it's when they discovered the games on it.
Oh yeah, you can put ROMs in here. I'm just like it's too much. There's one that floats around here from time to time.
I don't have all of games, but I just have the games that I play with.
Yeah.
Which are math.
Yeah, I realized what I did. I forgot some kind of
Yes.
4, 4, 5, 5. I did 5. Sorry,
That's all set. So your calculator is not calculating. So what I would recommend for that is well, it's because
You had it down here.
that's too much. So you're better off.
I was late. I wasn't there the day that we started, and he didn't tell me about it until Friday. And I had to go wrong.
Do that part there right again. Alright, everybody, here we go.
I did.
Alright, I don't want to take up too much of your time. Let's. Okay. What were the first 5 terms in the sequence? Started with 5, then what? 15, 45, 5, and then 4 or 5. Good. Okay, so then how many, because I can't find my pen, I'll find it in a moment. What was the amount of cells if they were to divide for 13 divisions? What would be the answer for this?
6, 5, 7, 2, 0, 5.
Okay, so that means that we end up with 2,657,205 cells. Okay, what happens if they were to split in 16 divisions? What do we get? 4. So 71,744,535 cells, right? If you're following that pattern, you will be fine. I do want to warn you as well. Man, I really wish I didn't lose my pen just now. But, well, for my Apple Pencil. I'm an idiot. Okay. Real quick. On Delta Math, it might not let you, there's a portion where they'll ask you to write the explicit formula. You want to reduce it as much as possible. We wrote it a couple times when it was reduced. It's looking for something like this on your Delta Math assignment. Well, let me do it in a different color. This is how Delta Math wants to see it. And they already tell you what A sub n is. But they'd want to see it something like this, right? Particularly, they want to see it, where'd it go? Like this, A sub, well here, let's do this one. They would want 1 times r raised to the n minus 1. That's how Delta Math will want it. This is to calculate any term in the sequence, any n term in the sequence, so the nth term. Real quick, if you can't put minus 1 in the exponent, you might want to put it in parentheses. That'll help you. If it doesn't let you. Sometimes it will, for the most part it will. But if not, then just put it in parentheses and you'll be fine. Okay? Questions, anybody? All right, rest of the time is yours to work on your Delta Math assignment. Let's get it.